ना recording on. अच्छा. Okay, so today we will start from problems on continuity and differentiability, because in the last class we have some theoretical explanations of rigorous explanations on continuity and differentiability. What are the conditions of continuity, properties of continuity, especially a lot of theoretical, and when does a function is differentiable, continuous, types of continuity, removable continuity, jump discontinuity, removable discontinuity, and non-removable, and there is an infinite discontinuity, oscillatory discontinuity, especially the functions of type x sine 1 by x, that type of x cos 1 by x. So this types of most of the theoretical portions are covered. Almost we have tried to cover the portions from the mains and advanced level. So let's do problems, and while we solving some problems, we will do more knowledge on that, maybe the graphing. Okay, later on. Okay. So first problem, the function fx equal to x minus modulus of x minus x square minus 1 less than equal to x less than equal to 1 is continuous in the interval, first option -1 1, second option open bracket -1 1, third option -1 1, sorry, -1 1, -0, and the fourth option is so I will start. You have to concentrate on the modulus, right? This modulus x will be less than equal to x square or x will be greater than equal to x square. What is the definition of mod x? X when x is positive, minus x when x is negative. So I will include that. So your solution, you have to write in a mode when x less than equal to x square. That is x minus x square less than equal to 0. So this will be negative. X less than equal to x square. So x minus x square will be negative, right? Or x belongs to -1 0. In this range only, x is less than equal to x square. X belongs to -1 third bracket. Close bracket. Oh, your answer is option C. Let's check. Oh, sorry. This will be O2. Correct. And close. It can take -1 also. If you put -1, it will validate. If you put 0, it will validate. So it's closed. It's included. So what is your fx? Right? Right? So this is y equal to minus x square plus 2x, right? Correct? Check my calculation. This is minus. And if this holds, then it's gonna be minus of x minus x square. So that's minus means plus. So it's a parabola. Vertex is at 1, 1. And another case, that is x belongs to 0, 1. So what is your fx? Y equal to x square. This is also parabola. Clear? Now if you want to draw the diagram, is this calculation over? Have you understood the two cases? Case 1, case 2. Because whenever there is a modulus problem, you have to do like this. One is a positive, one is a negative. So if it is negative, that is x less than equal to x square, x minus x square less than equal to 0. X belongs to, that is x belongs to this range. This is a negative. And this is valid for -1 and 0 also. And if x greater or equal to x square, this is positive. This value is positive. So your fx will be x square. In both the cases, you are getting a parabola. Now I want to draw the two parabolas, and from the graph, I will explain this is whether it is continuous or not. So -1 to 0, this graph. This vertex is 1, 1, and it's negative, so it will be like this. 1, 1. This is a parabola. This is negative, so that is why it is downward, concave down, because of this negative. If it is positive, it could have like this, upward. So -1 to 0. -1 to 0 means this is -1. This is 0. So this is the portion, right? Okay. 0, 0. Is it satisfied by 0, 0? Origin? Is this satisfied by origin? Yes. So it will pass through the origin, right? This is the portion. And y equal to x square, or x square is equal to 1, this portion. This is y equal to x square graph, and this is your this parabola. Have you understood the point?
Yes, sir.
This would be like I'm not drawing this portion because you are between -1 to 0, you have to draw this parabola, and from 0 to 1, you have to draw this parabola. So this is continuous. See, this is clearly continuous in -1 to 1. So your option is E. If there is an interval, in any interval you have to check. If any interval you have to check, you have to draw the region. By for your calculation, for your check. Okay. Otherwise, you could have tested for -1, 1, 0, 3 points minimum. Because in the interval it is continuous means it is continuous at all the points in the interval. If any function is continuous in an interval, that implies the function is continuous at each and every point of the interval. Okay, clear? Any questions? A. It is continuous at 0 also. There is no break. See the graph. If you have drawn the graph, please check. It is continuous at 0 also. So that is the confusing part. Sometimes, because if there is a range, if there is an interval, if they are talking about in the problems, they are talking about an interval. If it is at a point, you can easily check at a point. How will you check upon at a point the continuity? Left hand, suppose the point is A. So right hand limit equal to left hand limit equal to functional value at A. This is the criteria for continuity. At a point, but if they are talking about an interval A to B, how will you check? That means you have to check 2 or 3 points in that interval or any specific point inside the interval. If it includes 0, if anywhere within this interval there is a 0, then you have to check the continuity for 0 at 0, whether the function is continuous at 0 or not. That's my point. So it's better to, if you know the region, because it is a very easy diagram for parabola. If you know the vertex of the parabola, you can easily draw the parabola. And plus minus decides the parabola will go up or down, concave upward or downward. That's it. Draw the parabola and just decide. So it's your graph shows clearly at 0 it is continuous. Okay. Next. Let fx equal to then Which one? This is this one. No, this is the two part actually. If x not equal to 1, this one, x equal to 1, 0. Yes, yes, yes.
This question continuously.
Yes, 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 definitely. No graph, not good. Can you recognize the pattern? Just to recognize the pattern. So they are talking about the differentiability. So main thing is if the function is differentiable, it is continuous. But continuity doesn't ensure the differentiability. Okay. Acha. Before solving this, what about this function? Is it continuous? It is differentiable. It is differentiable at 0. This function. Okay, let's check. How will you check the differentiability? F dash 0, right? Limit x tends to 0, fx minus f0 by x minus 0, because I am checking the differentiability at 0. And this function is x not equal to 0 and 0 for x equal to 0. This is the function. So I have to check the limit for that, because left hand derivative and right hand derivative both will be fx. But in both the cases, it will be x sine 1 by x. In both the cases. So x sine 1 by x minus 0 by x sine 1 by x. What about the last line? Is this limit exist? No, this one. Is this correct? The calculation part. Now the question is, does this limit exist? Look at here. Look at here. Does this limit exist? No, never.
No, sir.
Sine 1 by x. It doesn't exist at 0. Doesn't exist at 0. 0 exists korche na. So that it is not differentiable. Doesn't exist. Doesn't exist. That is continuous. This again, please write the example. Once again, please write the example. This function is continuous at 0. Because why this is continuous? Because if you take the limit x tends to 0 fx, that's gonna be 0, and that is equal to x0. Because it is a product of the two functions. Limit of one of the function is 0, another function is unbounded at 0, like bounded at 0, but doesn't limit doesn't exist. Infinite limit or limit does not exist. So that product will be 0. The limiting value will be 0, and the limiting value is equal to the functional value at 0. So that satisfies the criteria for continuity. The function is continuous, but it is not differentiable. Continuous but not differentiable. Option D, B. Okay, clear? Now whatever. Here you have x minus 1 and 1 over x minus 1. So this is not differentiable at 1. Instead of this, it could have been x minus 2, 1 over x minus 2. So that is not differentiable at x equal to 2. So in general, if we write x minus a sine of x minus a, this function is not differentiable at x equal to a, but it is continuous at x equal to a. So take a note of that. In general, without calculating anything, no calculation is required, nothing to show, because you know this result. You know this result. With the help of this result, you can explain it. So this function is continuous at x equal to a, but not differentiable at x equal to a. Now what about 0? So not differentiable at 1. That means your option is either D or B. D or B. I don't know what about 0. What about 0?
-1.
She is correct. Option is B. But I have to test. I have to confirm this. So I will check for this function. Maybe the left hand derivative, okay. Right? Okay. So this is your. What about this one? If you, okay, you have denominated, it is differentiable at 0 or not? That you have to test.
স্যার জিরোর এগেনস্টে লেফট হ্যান্ড লিমিট আর রাইট হ্যান্ড লিমিট কেন নিচ্ছ?
একই নিতে পারো, no, not required. You can take greater 0. What about this limit?
স্যার এটা ডিফারেন্সিবল হবে,
Yes.
sin x বাই x এর ফর্মে নিয়ে আসা যাবে এটাকে।
Yes, correct. It is differentiable. You can check the limit, it is differentiable. So your option is B. Check kor. Okay. So this is a very good example. With the standard result, you can, without any calculation, you can check. Next, number 3. If fx x log cos x by log 1 plus x square, x not equal to 0, equal to 0 when x equal to 0, then fx is option A, continuous as well as differentiable at 0. Option B, continuous but not differentiable at x equal to 0. Option C, differentiable but not continuous at x equal to 0. None of this. So you have to check the continuity as well as the differentiability. First you check the continuity. Continuity at 0. Check the continuity. Then you have to check the limit. Limit x tends to 0 f x. So I will check the limit of this function. Limit x tends to 0 f x. And for both the cases, left hand limit, right hand limit, the function will be this one. Because it is not equal to 0. That means for left hand cases, you have to consider this. For right hand cases, you have to consider this function. X log cos x over log 1 plus x square, right? So that's gonna be limit x tends to 0 log cos x log 1 plus x square over x square. So it's 1 by x. Just check my calculation. This is 1 standard limit. Limit x square tends to 0 log 1 plus x square by x square, that's gonna be 1 standard limit. Log cos x over x. So 0 by 0 form.
Tan x by 1.
0 by 0 form, right? L'Hopital's rule. This is 0 by 0 form. So let's apply L'Hopital's. Differentiating the numerator. 1 by cos x, that means minus tan x over 1. Please check. So 0. And that is equal to f0. So the function is continuous. Continuous at x equal to 0. So your option A, B. Either A or B. Now you have to check differentiability. Check the differentiability. Is that clear? Continuity part is clear? Is this clear? I will take a test after completing differentiability. Function limit continuity differentiability. MCQ test. Later on, I will discuss later. So function is continuous. Confirm the continuity. Now you have to check for differentiability. Yes, Ishan, Dipayan, can you tell me whether it is differentiable or not? So f dash 0, right? Limit x tends to 0, fx minus f0 over x minus 0. I'm applying the formula. Now this is limit x gonna be 0. What is your fx? X log cos x, and this is 0. So x log 1 plus x square, right? You have x in the denominator already, so that x. And this is fx by x, because f0 is 0. So x got cancelled. So it's 0 by 0 form. Log cos x by log 1 plus x square. That's 0 by 0 form. L'Hopital's. So minus tan x in the numerator. And 2x over 1 plus x square. Applying L'Hopital's. Limit minus tan x over x into 1 plus x square over 2. So limit x tends to 0, tan x by x 1. So minus half. So left hand derivative and right hand derivative both will be minus half. So derivative exists at 0. So function is continuous and differentiable at 0. That means option A. Function is continuous and differentiable at x equal to 0. Box. Everywhere continuous. Option B. F is everywhere differentiable. F is a constant function. None. What will happen? Box sine square x. So what is the range of sine x? -1 to 1. What is the range of sine square x? So what is the box? Or you can put close bracket here also. So what is the box of sine square x? 0. It's a constant function. Now the question is, what about the continuity and differentiability of the constant function? What about the continuity and differentiability of a constant function?
Break.
Sir, not continuous but differentiable.
Constant function.
Yes, sir.
Okay, tell me one of the constant function. Any constant function. Fx equal to 3.
স্যার ডিফারেন্সিয়েট করলে তোমার 0 আসবে আর তোমার কন্টিনিউয়াস হবে না।
It is continuous.
আচ্ছা তাহলে both differentiable and continuous.
Only thing is that the derivative is 0.
Yes sir.
Derivative is 0. Any kind of constant function, the derivative will be 0. It is continuous. So think about these questions, okay? Box is not continuous. Box is not, but function is 0. Box is not continuous. If you want to draw sine box x, box sine x, this is your sine x. This is your 1, this is your 0, this is your -1. Now, how will you draw the box function? Any kind of box fx. How will you draw box fx? Draw a horizontal line. First, you mark the integers on the y-axis. Please remember, if you want to draw any kind of box fx. Once again, I want to repeat the graphical part. I want to draw any kind of fx. It can be polynomial, it can be trigonometric. So I want to draw box fx, greatest integer function, and the function is inside the greatest integer function. So the rule is, first you mark the integers on the y-axis. This is your y-axis. So already marked. Only 3 integers have been taken because the graph is confined between -1 and 1. Draw horizontal lines. And already the horizontal line is x-axis through 0. That is why nothing you have to worry about. Now, just choose the points where the horizontal line intersect the graph. So you have here, you have here, you have here, you have this point also. So from that, draw vertical dotted lines. 0 also. Already through 0 the lines are there. See? Here, if the function is increasing, now from these intersection points, draw horizontal, just hold the horizontal line, and if it is increasing, make a right end blank. So just like this, I have taken this one. This is the horizontal portion, so your box will be this one, because the function is increasing. So this is your box. So 0 to pi by 2, your box will be 0. Again, you are coming. This is also at this point at pi by 2, you have a discontinuity. Again, you are decreasing. Your function is decreasing. This is your box, and also this is your box. This is your box, because it will take only integral values, either 0 or -1 or 1. Am I clear? How to draw the box functions? Similarly, you should try for box cos x, box tan x. Yes. Suppose you want to draw box x cube. Similarly, draw the x cube function. Draw horizon. First, you draw the integers on the y-axis. From integers, draw horizontal lines. Dotted. From these dotted lines, where the curves intersect, draw vertical dotted lines. Now, from these intersection positions, this is increasing. It will not cross the vertical line. So these are the box. After that, you can rub these portions. You can see the clear picture of the box. I don't need this. So see, these are the box functions, only taking integral values. That means in 0 to 1, it will take 0. 1 to C, 1. And this portion is decreasing, so you have okay, clear? So this is the knowledge how to draw the box effects. Next question. Let fx equal to mod x plus mod sin x. X belongs to then f is continuous for all x belongs to continuous and differentiable everywhere. Nowhere differentiable. None of this. Tell. Answer. Acha, what about mod x? Just consider mod x. What about the differentiability of modulus of x? What about the differentiability of modulus of x? Is
Sir,
it
differentiable at every point except 0.
except 0? Because there is a sharp peak or corner point at 0. So it is not differentiable at 0. Okay, that is for mod x. What about mod sin x?
Sir, I guess the answer for this question will be B.
Yes, correct. Correct. So what about mod sin x? This is mod
Yes, sir.
modulus of sin x. So it is not differentiable 0, not differentiable at pi, not differentiable at 2 pi, infinite number of points. There are many points where it is not differentiable. But my concern is 0. I think minus pi by 2 to 3 by pi by 2. That means you have 0 on it. Okay. So without any calculation, you can guess, you can take a guess of that the function is not differentiable at 0.
Continuous at every point, but not
Yes,
differentiable at 0. The option A
continuous.
should have been continuous continuous at every point, differentiable except 0. But it is written continuous except 0.
So your option will be D. And if you want to draw the diagram for mod x plus mod sin x, it will be like this. It will be like this. Beautiful diagram. You can check the diagram at your, some application is there. Desmos. You can check several, you can check the points and all that. You can click the points. You can taste and again, this is curve. This is not straight line. ওটা দেখতে হবে because you have several points na intervals change the mod sin it will be sometimes it will be positive again this is negative positive combinations always. Yeah, there will be several points plus minus combination of the graph you can check. Mod cos x, you have to take mod cos x. Also not differentiable at many points because this is 0. At 0 cos x is differentiable, not cos x. But what about this point? This is pi by 2. At pi by 2 it is not differentiable. At minus pi by 2 it is not differentiable. Next is 3 pi by 2, right? Not differentiable. Graph will explain everything. Limit, continuity, differentiability, everything can be explained by the graph. I told you, graphical part is the most important part of calculus. If you know graphs, if you can handle graphs, you can explain it. See, I haven't calculated anything. I just know the graphs. And in MCQ, you have to do it like this. There is no time to calculate. In some problems, you have to calculate. But in just like in problem 2 or 3, there is some limiting calculation, like there is a differential. That we cannot help it because you have to do some calculations of that. Otherwise, if you know the graphs of entire functions, all the maximum answers will be answered in the paper. How? No, not long. Timetable, it depends. What is the time? 180 marks paper. So 3 hours you have.
No, Jayden.
It means 25. 75 questions. 75 questions, 3 hours. 300 marks. 3 hours. Right? 3 hours.
3 hours. 3 hours are and extra 5 questions. Maths or the integer type.
Next question.
0 or minus.
Which of the following functions have finite number of discontinuity in R? It's very easy question. It will take only few seconds.
Sir, that is X box X, right?
X box X,
Okay, sir.
mod X by X, and
Sir,
time box by X.
C একটা হবে সেটা তো দেখে বুঝতে পারছি।
Yes.
C একটা অপশন হবে।
C, one of the option is C. Only one option. Finite number of discontinuity. This tan X have infinite number of discontinuities. If there is a box that have
স্যার এটা
infinite
তো
number of
স্যার
discontinuities,
বিটা তো ইনফাইনাইট নাম্বার অফ ডিসকন্টিনিউটি,
এটাও
এটাও
infinite.
ইনফাইনাইট হবে, সিটাই শুধু থাকবে।
Only mod X by X.
স্যার চারটে ডিসকন্টিনিউটি
একটা zero.
না স্যার, দুটো এন্ড যদি আমি নিই,
What is mod X?
স্যার গ্রাফের দুটো এন্ড যদি নিই তাহলে তাহলে আরো দুটো হবে না?
Tan X.
X not equal to 0.
স্যার শুধু -1 আর 1 আসবে।
So at 0 it is the discontinuity. Only one discontinuity. Only one discontinuity. Okay. Let f from R to R is a function from real number to real number, real value function is defined by fx equal to max of x comma x cube. Find the set of all points where the function is not differentiable. Option A -1, B 0, C 1, D all of the above. Not differentiable. It's a very interesting question. Again, we have some graphical knowledge is required for that. Maximum of x comma x cube. Okay, first 0. Okay, your answer is 0.
Sir, just a second.
Deepayan, you want to answer?
Sir, trying.
Okay. First, I will try to draw the graph of max of x comma x cube.
Sir, all of the above হবে কি?
I think you are right.
হ্যাঁ স্যার, all of the above হবে। কেন কি 0 তে একবার ব্রেক হবে, 1 এ আর -1 একবার ব্রেক
This is
হবে।
y equal to x and y equal to x cube. Okay. Like this. This is your y equal to x cube function. Now the question is maximum. You see, maximum of these two graphs. So you have to take the maximum portion. Look at that. What is the maximum portion? This is the maximum portion. So let me reduce this with a dot. This with a dot. This with a dotted curve. And this with a dot. Can you see the maximum part? If it would have been minimum of these two functions, you have to take the lower part. So can you find the corner points? One is here, origin, and so this point is basically 1. How? If you solve x equal to x cubed, you will get 3 points. X square minus 1 equal to 0, so that's going to be 0, minus 1 and 1. So these two graphs will intersect at 3 points. How will you get the intersection points from two graphs? So geometry is also required. Just solve these two graphs. Solving. Clearly, by solving, you are getting 3 points. 0, minus 1 and 1. So this is going to be 1, 0, and this is going to be 1. So these are the corner points, not differentiable. You cannot draw triangles at these points, sharp peak or corner. So these 3 are the discrete points of non-differentiability.
Sir, will you please send the questions after the class?
Yes, sure. You will get an assignment on this. Can I rub this? Next question. A function f from R to R satisfies the equation f of x plus y, fx into fy for all x comma y belongs to R, fx not equal to 0. Suppose the function is differentiable at x equal to 0 and f dash 0 equal to 2, then f prime x is How do you know? Remember the answer. Okay, very good.
Y equal to 2 and
Very good, very good.
dash y equal to 2 and y are f dash x equal to 2.
Yeah, f dash 0 is 2. So if f dash 0 is 2, you can write from the first principle limit h tends to 0 fh minus f0 or 0. Okay. Right? Okay. This is the thing. Now you want to find out f dash x. What is your f dash x? Limit f dash x, right? Yes. Limit correct? First principle. This x can be written as f of x plus 0. Because of this property. F of x plus y is fx into fy for all xy belongs to R. This is nothing but your 2, so it's twice fx. আমি বলেছিলাম বুঝছিলাম ওকে
হয়তো
okay okay next problem number 9 is the latest question. If a function fx defined by fx equal to a e to the power x plus b e to the power minus x minus 1 less than equal to x less than 1 c x square ax square plus 2cx. Yes. This is a very latest question of JEE. Be continuous for some ABC belongs to R and F prime 0 plus F prime 2 is E. That means F is differentiable. If these values are given, that means F is differentiable. Then the value of A is you have 4 options. Just tell me what will be the value. This is the latest question actually. 2020 or 21. Continuous. Continuity at 1 and 3 because you have a 1 and 3 as the intermediate point. So the function is continuous at 1. Limit x tends to 1 minus fx
Sir, irrespective of
So 1 minus the first function a e b to the power minus 1 c. This is equation 1. Correct? Continuous at x equal to 3. Left hand limit at 3. Right hand limit at 3. Equal to functional value at 3. So that is 9c equal to 9a 6c, equation 2. You need another equation because you have 3 unknowns ABC. You have three unknowns ABC. So you need another equation to solve these three. What is the another one? You have another one. This is differentiability. What is a plus 0 and a plus 2? A plus 0 means in this range. 0 is in this range. You have to differentiate this one. So a plus 0 will be, a plus x will be a e to the power x minus b e to the power minus x. 2cx. Right? This is your derivative part. So what is your a plus 0? A plus 0 will be a minus b and a plus 2 will be 4c equal to e. Solving this 1, 2, 3, you will get the answer. I'm not wasting time to solving these three. This is the calculation. Any questions? Have you understood?
So can you read equation 3 once?
3. Okay. Have you understood this derivative part?
Yes, sir.
A plus x is a e to the power x, b minus b e to the power minus x in this range, twice cx in this range, and 2ax plus twice c in this range.
Yes, sir.
Now you have another relation given in the question. F prime 0 plus f prime 2 equal to e. So what is your f prime 0? If 0 is 0 lies between minus 1 and 1. So f prime 0 will be a e to the power 0 minus b e to the power minus 0. So it will be a minus b.
Okay, sir.
And what is your f prime 2? 2 is between 1 to 3. So it
Yes, sir.
must be 4c. So f prime 0 plus f prime 2 will be a minus b plus 4c equal to e. This is the third equation. Solving 1, 2, 3 for ABC, you will get the answer. You have to find A. Just you need to find A. So from the first two, you can eliminate C. From the last first, after that you will use 3 to eliminate other B. So you will get A finally. Okay? Understood?
Yes, sir.
Okay, next question is the function fx equal to 3x minus 1 whole square into sin x ln 1 plus x not equal to 0. Is continuous at x equal to 0. Then the value of f0 is 2 ln 3 ln3 whole square, ln6, none of this. It is continuous. It has been, it is continuous. So what should be the value of f0? That is a simple question. What should be the value of f0?
So 1 plus x by x 1.
1. A, option A, no. So you have to take the limit at 0. Right? Done. This is 1. Limit x to 0 sin x by x1. Limit x to 0 ln 1 plus x by x1. Standard limit. And this is ln3 whole square. Correct? The Swapnil's questions are answered. He was talking about from the graph we have to check the differentiability. Those type of questions are answered. Next, fx equal to max of 1 minus x, 1 plus x and 2. Then fx is not differentiable at not differentiable at what are the points where the function is not differentiable?
স্যার
Yes,
ক্যামেরাটা
can
একটু
you
ডান দিকে সরে গেছে।
yes, yes.
হ্যাঁ স্যার।
What are the points?
Just a second.
Non-differentiable at 2 points, 3 points, 4 points, none.
Sir, non-differentiable and non-point হবে সব পয়েন্টই differentiable.
No point where it is not differentiable.
Yes, sir.
Sir, 4 points.
This is y equal to 1 minus x.
ও না না স্যার সরি আমি তাহলে y equals to 1 minus x এর এটা ভুল আঁকলাম এক সেকেন্ড দাঁড়াও
This is y equal to 1 plus x. This is y equal to 2. Max. Max of this.
স্যার দুটো পয়েন্ট হবে একটা হচ্ছে 1 একটা হচ্ছে 3
Is this correct mud diagram?
yes sir
So 1. This is minus 1, right?
yes sir
And this is 1.
yes sir
Max of only 2 points, 1 and minus 1. Max of the function, not mean. Max of the function is this upper part. So you have corner at minus 1, you have a corner at 1. So only these 2 points are not differentiable. Next, if f from, is this problem number 12? Satisfies less than equal to mod x minus y whole cube and f4 is 192, then f7 is equal to this is one of the important problem. The concept is very important. And you have to remember this problem. Okay. I'm taking limit on both the sides. Okay. Right. Ishan Dipayan.
Yes, sir.
Yes, sir.
So this is nothing but your f dash. This is nothing but your differentiable. First principle. And on the right, if you y tends to x, this is gonna be 0. So modulus of f dash x never be less than 0. Only possibility is equal to 0. So which implies fx is a constant function. Because only the constant function has a derivative 0.
তাহলে স্যার অপশন এ হবে।
তাহলে f7 will be 192. One second. f7 is 192 because f4 is 192 is given. The constant value is 192.
So 192.
The concept is very, very, very important. And how the technique, how will you solve the problem? That technique. Is that clear, Ishan Dipayan?
হ্যাঁ স্যার।
Like fx is a constant function, that is why the value will be 192 constant, right?
Yes, because it's a given f4 is 192.
Yes, sir.
So if it is f4 is 192, f7, whatever the 7 is not a matter, doesn't matter.
So like any input will turn out to be 192.
Whatever be the value, it will be 192. 192.
Okay.
192. If fx equal to p mod sin x plus q e to the power mod x plus r mod x cubed and if fx is differentiable at x equal to 0, then C রিপিট হলে তো পেরে যাবে একটা কোশ্চেন।
এটা বহু বৈশাখ না এই বিলগম
Previous year. So you don't know differentiability at that time. Then you are learning differentiability at 12. Main concept. So main thing is you have to check the differentiability. Left hand derivative, that's 0. Minus p sin x plus q e to the power minus x minus r x cubed. And what will be your f0? Because what is the formula for differentiability? Limit x tends to 0 fx minus f0 over x minus 0. This is the formula or principle. So now applying, this is your fx. When x tends to 0 minus, and what is your f0? F0, this is 0 q. Q is f0. Your f0 is q. e to the power 0 is 1. f0 is q. Okay. Now minus p sin x over x plus q. Okay. X square. So limit x tends to 0 sin x by x 1. Limit x tends to 0 e to the power minus x minus 1 by over minus x. You have to put some minus 1. And this is 0. So it is minus p minus q, right? Please check. The limit will be minus p and minus q. Minus p minus q. Is it correct? What about the right hand? What about the right hand limit? P plus q. So right hand limit will be right hand derivative. Okay. So as the function is differentiable at 0, these two must be equal. Which implies p plus q equal to 0. R is any real number. Okay, everybody. Is that clear? Ishan, Dipaya?
Yes, sir.
Okay.
Yes, sir.
if x equal to equal to 0, when x equal to 0 is continuous, x equal to 0, then option A, f0, oh, f0 is not given, sorry, f0 is not given, only this, f0 is 5/2, box f0 is -2, fractional part of f0 is -0.5. Now, box f0 times fractional part of f0 minus 1.5. Yes, that you have to do. I will not solve this problem. You have to answer the question. What is the limit? Is it 0/0? Well, find the limit. What is the limit, Isha? It is 0/0. So half,
Sir, I guess it will be option D.
option D, correct. Very good. That means what is the limiting value? Minus 5/2, right?
Yes, sir.
তাহলে box of -5/2 and fractional part of -5/2. Very good. If fx equal to 8 to the power x minus 4 to the power x minus 2 to the power x plus 1.
Sir, box of f0 and fraction part of f0 is -3/2.
X positive. X less than equal to 0 is continuous at x equal to 0. Then the value of lambda is lambda. Answer. Hurry up. This is easy. What is the limit? Zero plus. ln2 ln4. What is the value of lambda? And that should be equal to f0 for continuous. And your f0 is ln4, lambda ln4. So lambda has to be ln2. Clear? Next day we'll have more advanced questions. Lot of questions of continuity differentiability. After that we go to the next chapter. If this is the last question today's, a cos x
No.
ln2 ln4 equal to f0. F0 is ln lambda ln4. So lambda is
Lambda log 4.
that is ln
The natural logging comes.
natural no natural. f0 equal to 4 is continuous at x equal to 0. Then the ordered pair a comma b is first of all check the limit. For the function to be continuous, the limiting value should be equal to f0 equal to 4. This is 1. If you put 0, this is 1. Cos 0 is 1. Cos 0 is 1. So a minus 1 in the numerator and in your denominator is 0. So for the limit to be exist, because this limit exists, otherwise it cannot be continuous. Continuity implies existence of limit, but the converse is not true. Continuity implies existence of limit, but the converse is not true. So continuity implies this has to be exist. This limit exists. So this has to be of the form 0 by 0 form for existence. That means if denominator tends to 0, yes, as x tends to 0, the numerator should tends to 0. So for that, a has to be 1. Otherwise it cannot. Got my point? For existence of this limit, how did you get the concept of existence from the continuity? It said, it is mentioned in the question, it is continuous. If it is continuous, the function has to be, limit has to be exist. So for existence of limit, this form will be 0 by 0 form. So as x tends to 0, denominator tends to 0. The numerator has tends to 0 also. For numerator which tends to 0 means a equal to 1. Otherwise the limit doesn't exist. Is that clear? So if a equal to 1, this is now 0 by 0 form. L'Hopital's rule. Oh, plus. Again, you have 0 by 0 form. 0 by 0 form. Two. And this has to, now you put 0. So it will be b square minus 1 by 2. And this has to be equal to 4. So b is plus minus 3. A1 b plus minus 3. Option B.
Sir, cos x by x square will effectively have to value.
No, 1 minus cos x by x square. Clear? Okay? Okay, Deepayan?
Yes, sir.
Okay, in the next class, we will solve more advanced problem on continuity differentiability. There are some advanced problems today. Well, we'll talk about more advanced problem. And if time permits, in the next class, we'll go to the next chapter. Maybe we'll start with inverse trigo. Okay, take care, all of you.